A very good morning to all of you. My name is Sona. Today I'm going to tell you about the topic circles. You all might have been familiar with the topic circles. You might also have come across various round objects in your daily life. As I can also show you, can you see the clock is also round in shape, which means it's a circle. Just like this, you can see this is a lid which is also round in shape and a circle. So how to draw a circle on a plane? If I take a fixed point and start making different points at an equal distance from these points and join all of them together forms a circle. So basically, what is a circle? Any closed shape with all the points connected together at an equal distance from the center is what we call as a circle. And the center is any point on the boundary of the circle at an equal distance is what we call as a center of the circle. So now the center of the circle and the distance between the center of the circle and any point on the boundary of the circle, if we join together, these forms the radius of the circle. So there can be multiple radii. So the distance between the center and any point on the boundary of the circle is the same, which means all the radii are equal. Now comes the chord of a circle. Now what is a chord of a circle? Any line segment. A line segment which means any line segment which means a line which has 2 points, a starting and an ending point is what we call as a line segment. So any line segment that we draw inside a circle is what we call as a chord of a circle. This is the center and this is what we call as a chord of the circle. Now again, if I take another 2 points and join together is what we call as a chord of the circle. So similarly, we can have various chords inside a circle. But the chord that passes from the center of the circle or which cuts the center of the circle, or we can say which bisects the center of the circle, is what we call as the diameter. So now diameter is also called the longest chord. So basically, see, if this is the center starting from here up till here, this is the radii, this is the radius and this is also another radii. So now diameter is equal to twice of the radius, as you can see here. So diameter is the twice of the radius, which means 2 times the radius. Then comes the segments of a circle. Circular segment. As the word says, segments, which means the part of the circle. Now if I draw a circle, any chord that cuts the circle, any chord that bisects the circle, if I have a chord PQ and this is the center O, so the chord that cuts the circle in 2 different regions is what we call as the segments. So here we have a smaller segment and here we have a bigger segment. So the bigger segment is what we call as the major segment. The smaller region, the smaller portion is what we call as the minor segment. So now comes the arc of a circle. Now comes the arc of a circle. The shape of an arc is like this. So if I make a circle and 2 points on a circle, the distance, the portion between the 2 points of a circle forms an arc of a circle. So this is the portion which forms the smaller arc. This is also an arc of a circle which covers the larger portion of the circle is what we call as a major arc. This is the minor arc. As the word says, minor, which means smaller, and it covers the smaller portion. This is what we call as the minor arc. So, and this is the major arc. Next comes the angle subtended by a chord. Angle subtended by a chord. Now what do you mean by angle subtended by a chord? If I have a chord PQ or a line segment here, and if I have a point R. Now if I join the point R with P and R with Q, the angle formed with the PQ chord is the angle subtended by the chord PQ, which means angle PRQ is the angle which has been subtended by the chord PQ. So if I draw a circle, this is the center O, this is the chord PQ, and if I take a point R here and join PR and PQ, so this is the angle which has been subtended by the chord PQ. Now if I join OP and OQ, this is also the angle which has been subtended by the chord PQ. Now there is a theorem which says two equal chords subtends equal angles at the center. So now two equal chords subtends equal angles at the center. So how we can prove this? If I have a circle, the center O. Now if I have a chord here AB, a chord CD. Let us assume the AB and CD are the two equal chords. If I join AO and OC here, if I join OB and OD, so these are the angles which have been subtended by the chords AB and CD. As you can see here, there are two angles, angle AOB and angle COD. So as per the theorem, angle AOB needs to be equal to the angle COD. But to satisfy this theorem, we need to satisfy three conditions. So the three conditions which helps us to prove angle AOB at the center is equal to the angle COD. So here, see, OB is equal to OD. Why? Because OB is also the radius and OD is also the radius. So being the radii, so I told you the radius of the circle are always equal. So OB and OD are the radii. So one condition is satisfied. Another thing here is OC and AO. OC is equal to AO. This is also the radii of the circle. And now we only assume at the center, at the starting, that AB and CD are the two equal chords. So which means I have 1, 2 and 3 conditions which satisfies. So this means angle AOB is equal to the angle COD, which proves this theorem that the two equal chords subtends equal angles at the center. Thank you.